Hi everyone, in this video we'll be learning about rational numbers. If you were to look at rational numbers, one way to understand rational numbers or memorize what rational numbers are is to look at the first 5 letters of the word rational. Of course, it's not the English meaning of rational, it's a mathematical idea. The first 5 letters is something like, it's spelled ratio, and it reflects a primary school idea where ratios are similar to fractions. They just show a proportion of a particular quantity over another quantity. So basically, rational numbers are numbers that can be expressed as a fraction. And of course, you have many examples of these. So for example, we have 3 over 4. 3 over 4, of course, itself is a fraction. So definitely it can be expressed in fractions. And also you have your mixed numbers, and you have your improper fractions like 17 over 2. Okay, one thing about rational numbers is that they can also be whole numbers. So for example, 13 or 7. You might be thinking, why is 13 and 7 a rational number? So for example, look at 7. You can rewrite this as 7 over 1. Okay, rewrite this as 14 over 2. In this way, you can understand they can be expressed as a fraction. After which we also have things like our square root 4 over 2. What is square root 4 over 2? Essentially, it's just 2 over 2, which gives you a fraction itself. All these are examples of rational numbers. So it's the value that you have in the end. So even if things like cube root 1 to 5, we will consider this as a rational number because if you cube root 1 to 5, you get 5, which itself is a whole number or an integer, which we know that they are rational already. You might think, hold on, wait a minute. What about numbers like 1 2/3? If you look at 1 2/3, you type in your calculator, you get the following answer: 1.666, and it goes on. So we rewrite this as 1.6 recurring, right? This is something we'll discuss later on. 1.6, and the dot means that is recurring. Just say by 1.6 recurring. We'll visit this later on, but for now you need to also understand that all recurring numbers are rational because they themselves can be expressed as a fraction. And this also includes non-recurring decimals such as 0.7. Why is 0.7 a rational number? Because it is 7 over 10. All these are things that we are familiar with in primary school. You can express a decimal as a fraction. So the opposite of rational numbers is what we refer to as irrational numbers. So what are irrational numbers? Well, basically they're numbers that cannot be expressed as a fraction. And we have a few famous examples. For example, your square root 2. You can type in a calculator and you cannot convert it into your fraction. You have things like pi. You have the natural number e. You can find your calculator, you can type e power 1 and so on and so forth. So all these are your famous irrational numbers. But what will tell you which number is irrational is just your calculator. You can press the button, and the button looks sort of like this. It's the button on the calculator that states S. Right? You can type it, press this button, and the calculator will tell you whether it can be converted into decimal place, converted into a fraction or not. So there we have it, the rational and irrational numbers. However, we did mention a point regarding recurring decimals. Recurring decimals. First things first, you need to understand how recurring decimals work. So for example, you have our previous example, 1.6 recurring, right? It is 1.666 ... We reverse this process and try for numbers like 2 over 9. What is 2 over 9? If you type this in the calculator, you get 0.222. And if you want to express this particular decimal or this particular fraction as a recurring decimal, you put as 0.2 with a dot recurring. So these are a few examples, but you also need to understand that we can have more than one dot in a particular recurring decimal. So for example, you have this number 70.234, 234, 234. To show, and it goes on forever, to show that it is a recurring decimal of such nature, we will write as the following: 0.234, and the dots we put at the top of 2 and 3, 2 and 4, so it shows as recurring. So another example would be like 9.23. How would you write this as a decimal? Well, it's just 9.2323 recurring all the way to the end. So when we look at recurring decimals, they have this property called, well, first of all, it is recurring. When something is recurring, basically they have a pattern how the numbers appear. And not only that, they share a similar property with our irrational number. They are non-terminating. One loose way of understanding what non-terminating means is that it goes on forever. So these are properties of our recurring decimals. And to sum up over here as well, our irrational numbers they share the property of being non-terminating, which means that it goes on forever. However, they are non-recurring, meaning to say no pattern to how numbers appear. Right, that's it. Our introduction to rational numbers, irrational numbers, and recurring decimal. Thank you.